In the petrol engine, the injection system replaced the carburetor. This resulted in a more precise formation of the fuel and air mixture. With electronic injection control, engines have become more powerful, reliable, economical, and environmentally friendly. With the development of new injection systems and the introduction of electronic control, engines have become much better for use in vehicles while respecting the needs of the market and legal norms on exhaust gas emissions. A different way of forming the mixture required the introduction of many new functions and components, and thus a different approach to engine maintenance and servicing. In the following lessons, you will get to know the elements and injection systems of petrol engines, their specificities, characteristics, and methods of maintenance, testing, and repair. With knowledge of the principles of operation and servicing procedures, you can determine and eliminate vehicle malfunctions more quickly and efficiently. Air intake elements. The injection system's role is to form an air-fuel mixture. The proper operation of the engine in all modes, and emission of exhaust gases, that is, the catalyst operation, depends on the mixture ratio of air-fuel. During the testing of the efficiency of the engine, the ideal balance of the composition of the air-fuel mixture was reached. It is the stoichiometric ratio of the air-fuel mixture. It was found that burning 1 liter of fuel requires 10,000 liters of air. If we use the mass balance of the mixture composition, burning 1 kilogram of fuel requires 14.7 kilograms of air. For an easier understanding of the ratio of the composition of the mixture, the excess air coefficient or lambda value was introduced. The coefficient of excess air determines the ratio of the composition of the air-fuel mixture to the ideal value. The lambda value is the ratio of the actual amount of air per 1 kilogram of fuel in relation to the theoretical amount of air per 1 kilogram of fuel. When the actual amount of air in the mixture equals the theoretical amount, it is an ideal mixture and lambda equals 1. When the amount of air in the mixture is smaller than ideal, then the mixture is rich and lambda less than 1. If the mixture is too rich and exceeds the limit of 0.85, the spark cannot ignite the mixture, and combustion and engine operation is absent. When there is more air in the mixture than the ideal ratio, then the mixture is lean. With such a mixture, fuel consumption and engine power are reduced. When the mixture exceeds the value of 1.3, it is no longer flammable. That is the upper limit of the lean mixture. Torque and fuel consumption depend on the composition of the mixture. From the graph, we can see that the highest torque is obtained at lambda equals 0.95 when it is slightly rich, and the lowest consumption is achieved at a slightly leaner mixture of lambda equals 1.05. A compromise was achieved for lambda equals 1, where we have a slightly lower torque with a slight increase in fuel consumption. That is why this ratio was chosen for the ideal mixture of fuel and air. With modern injection systems, during engine operation, the ideal mixture composition ratio lambda equals 1 is always maintained due to the exhaust system and the catalyst meeting the criteria of the exhaust gas emission norm. This topic will be discussed in the next lessons. Finally, to understand the operation of the injection system, we need to know what the engine's needs are at different engine operating modes. The task of the injection system is to adapt to different operating modes to meet the requirements for reducing exhaust gas emissions with maximum engine performance. Engine operating states are cold start, warming up, idle, part load, full load, acceleration, overrun, working at a higher altitude. When we have a cold start, the engine is not warmed up, the engine oil is thickened, it is more difficult to spread, and there is more friction between the moving parts of the engine. The mixture is cold, and the fuel condenses on the intake manifold walls, valves, and cylinders, which weakens the mixture. That's why more engine power is needed for starting. When a cold start is performed, the engine warm-up mode begins. It is necessary to provide the conditions for the engine to warm up as soon as possible and reach the operating temperature without impairing the emission of exhaust gases. When the vehicle is stationary, the engine is running at idle speed. A fine regulation of the number of revolutions is required to have a smooth engine operation. Otherwise, the unstable operation is transmitted to the entire vehicle, which impairs passenger comfort. Part load is at lower RPM when engine torque is high. In this mode, fuel consumption is lower with stable and quiet engine operation. Full load mode requires more engine power and more fuel for its operation. This mode is activated when the vehicle needs to overcome a hill or is under a full load. Acceleration of the vehicle is a special mode when the speed increases suddenly. For the engine to provide a higher power output, it needs more fuel. Slip drive is a motor braking mode. When the driver predicts that he has to slow down a bit, he releases the gas pedal. The system cuts off fuel injection, and the engine functions as an air compressor. The engine slows down when it compresses the air in the second stroke. Since there is no ignition and combustion, the vehicle stops quickly. At higher altitudes, the air is thinner and there is less oxygen to burn. The system in this mode should adjust the injection and mixture formation. With the introduction of injection, there was an improvement in the process of controlling the formation of the mixture and managing the processes of engine operation. The mechanics have not changed much, but with injection, there have been significant advantages in the engine operation itself. The advantages of the injection system compared to the carburetor system of mixture preparation. More precise mixture preparation in all engine operating states. Better cylinder filling. Higher torque and engine power. Lower fuel consumption. Fine dispersion of fuel. Faster fuel evaporation. Equal distribution of fuel to each cylinder. Shorter transport paths of the mixture to the cylinder. Greater elasticity of the engine during a sudden change in the operating state. Easier and faster engine warm-up. Better engine acceleration and engine braking. Lower exhaust gas emissions. To check the correctness of the injection system on the vehicle, the service technician should recognize the type and know how that system works, what elements it consists of, and which are its characteristics and specifics. Only in this way can he successfully determine the malfunction based on the symptoms of the malfunction. The injection system is an electronic engine control system. The central place is occupied by the electronic control unit, ECU, that monitors and controls all processes of the injection system and engine functions. The ECU controls the engine functions based on the received current data from the sensors and stored values via actuators. All engine and electronic control elements that act on the same area can be grouped into subsystems. Subsystems that can be considered separately are air intake, fuel supply, mixture formation, engine compartment, ignition, and exhaust. To understand injection, one needs to understand the role of each subsystem, the way it works, and the characteristics of its components. We will cover each subsystem individually, followed by the operation of the various injection systems. You can look at the ignition in the petrol engine ignition system lesson. First, let's see what elements the air supply system consists of and what their task is. For the correct operation of the engine, it is necessary to form a mixture of fuel and air. Air is taken from the environment and fed through the intake line to the engine, where the mixture forms. Air allows the fuel to burn inside the cylinder. The air must be cleaned to measure the amount that is ready to form the mixture and reach the cylinder. For delivery, an intake manifold is used, on which the following components are located: air filter, throttle, and throttle bypass. Most injection systems also have a return line where part of the exhaust gas is fed into the intake manifold via the EGR valve. Exhaust gas recirculation serves to control exhaust gas emissions. The air must be cleaned of impurities before it enters the intake manifold. That's what the air filter is used for. The air may contain dust particles from 5 to 50 microns in size and quarts. The concentration of impurities depends on the driving conditions, asphalt or dusty road. If it gets into the engine oil, this dust forms an abrasive film, which leads to extreme wear, especially on the cylinder walls, pistons, and valve guides. A dry air filter is most often used on vehicles. The filter retains impurities, and over time the air permeability decreases. When a sufficient amount of air no longer passes through the filter, the composition of the mixture is disrupted and the filling of the cylinder is reduced, which leads to a deterioration in engine performance. All vehicles have a prescribed air filter replacement period based on normal engine operation. However, when the vehicle is used in an adverse environment such as dust, the life of the filter is shorter. The air filter, in addition to removing impurities, also dampens intake noise. Without the filter, the engine would be noisier during operation. The replacement interval is prescribed by the vehicle manufacturer. However, when the vehicle is used in an adverse environment such as dust, the life of the filter is shorter.